All right. Ladies and gentlemen, it's a pleasure to have all of you here from the hustle and bustle of the weekend. I want to apply the envelopment analytics using a software that can do all the work for you based on the theoretical underpinnings you already have. Now, when you are doing the software and using it, you will appreciate it more because of the knowledge you already have. There are several softwares you can use to estimate efficiency, find slacks, identify mixed efficiencies, technical efficiency, pure technical, skill, targets, and so forth. There's software even that will draw the frontier, identify the observations in it for you. Some of the softwares are R and R Studio that move together. And it has some main packages like FEAR, Frontier Efficiency Analysis for R. Benchmarking is another package or library. DEAR is also another package. There are other packages within the R system. Another powerful software is the Max DEA. There is a professional version, paid version, but there is also another version for students or for those who want to just use the software to try and use it. It doesn't have all the features, but the main envelopment and multiplier models are there. There is efficiency management system by Shield, very useful for those that want to hold some portions of the frontier. Of course, R can do that now. LIMDEP is there to estimate both stochastic frontier analysis and that of the DEA. Lindo can be used to estimate linear programmings of all sorts, Lindo and Lingo, as well as the DEA. PIMS DEA software is very useful, very cheap. Even though you can buy it, it's still very cheap. And you can use that as well. And then you have the DEA frontier, you have the Banksia frontier, all of them are there. The key thing is to know at least 3 of these softwares. Sometimes it helps you to synchronize your results. We are going to use the R and the R Studio. So why are we using it? Because it has some very powerful things. You can manipulate it. You can even develop models with it. We will concatenate matrices to create larger matrices. We will combine, column bind, and row bind some matrices. Okay, so sometimes it's good to have some knowledge about matrices. The reason why we are using the R are the following. Free, vast community. Yeah, it has an independent platform. You can integrate it with other languages. It's trending. It's trending. So let's try to get some bit of knowledge about matrices. When you have a columns, and by the way, every blue thing you're going to see, you have to type it. Okay. Columns of 2 matrices have the same number of rows. And because you have 2 matrices, you can combine them to form a larger matrix. So if you take a matrix like B, this n row means that it has 3 rows. So 3 rows here means that it has something like 1 row, 2 row, 3 row. And then n col means that it has 2 columns. So it has a 1 and then 2. Therefore, when you have a complete matrix like this, and you are told that it has 3 rows and 2 columns, you have to apportion this data set or this matrix into the number of rows and columns. if the rows are going to be 3, it means that if you look at the numbers, you have to take them in such a way that you are going to have 3 rows and 2 columns. 3 rows, 2 columns. And you are dealing with the rows first. Okay. So how can we now split this into 3? There are 6, as you can see. So you have 3, okay, and then you have that, okay, because we are going to have 2 columns. So when you run this, and now we are going to go to the R to run this, then you can appreciate it. So I've typed my own here. So you want to type that. These are called preliminaries. So you want to do the same thing. So you run, you type the command B equals capital B equals to the matrix of, and then you bring a bracket and concatenate. That means you are combining or putting them together. 2, 4, 3, 1, 5, 7. Okay, or 2, 4, 3, 1, 5, 7. So you run this command, and then it will split it into 3 rows and 2 columns. You do that. And even if you don't know that it's going to be 3 rows and 2 columns, once you highlight the B and you run it, it will tell you clearly that you have 3 rows and 2 columns, which means that the 2, 4, 3 are reflecting the 3 rows. And then the 1, 5, 7 are also reflecting the next 3 rows, therefore creating the 2 columns automatically. So you can see down there in the console clearly how this matrix will look like. Which of you have done this? Chris, have you run it?
Yes, yes, not yet. I'm now typing. I was listening
Have you run
to.
it?
No, Doc.
Which one have you done? Which one have you done? Do you have the, what do you call it?
Okay.
Go to number 6 on your
Doc.
command.
Doc, please. Hello, Doc.
Hmm?
I can't see anything.
What is, you can't see Chris' screen. We are all watching the screen.
Yes. I can't see it. So
close everything and then, join the Zoom again. That's a reliable thing to do. Go to the next command and type D equals to matrix into bracket C, and then bracket again, type 6, 2. Step out of the first bracket, bring a comma, and type n row, that's the number of rows, equal to 1, comma, n column, NCOL.
N column or just column?
NCOL equal to 2. Okay. Run that. Go to the next one, type R bind, all small letters. R bind, so you're combining the rows. It will come, you select, and then into bracket B, capital B, comma, capital D.
Capital D.
For dog.
Okay.
Run that. So that is what you have just done. You have what you've done is that these were standing on their own, and you have, combined these columns. That is why you see that we use row bind. So you combine the matrix called B and the matrix called C. And now you've been able to get something like a data frame. So this is like a data frame. In fact, the column 1 can be inputs and column 2 can be outputs. All right, let's go to a proper data frame. There's a proper data frame inside there. So it's called plant growth. So start with capital P and then plant. And then the growth, only the gene becomes capital. Plant growth, one word. It has come. You select it. And that's it. You can run it and then see the result. Run it and show. Okay. So when you scroll up to the beginning, you can look at the head of this data. Anytime, suppose you see, you just scroll to the top. It was easy because it's short. But what if it's 1 million? You can't be scrolling like that. It will take a longer time. So you can look at just the head and the tail. So type head, small letter H, small letter. It will come, select it. And then you type the plant growth again in there. You run it, it will only show you the first 6 observations.
Yes.
You do the same thing for tail, it will show you the last 6 observations. You are learning. So this should help you to know that this is how you can see the top part and the bottom part of any data set. All right. Now, we are ready. You remember some time ago, not some time ago, the data set we did, the family data set we did for the 5 sample observation DEA that we drew. You remember we had it. You typed it in Excel. Do you remember?
Yeah. Yes.
Go open that Excel.
Let me see if I saved it. Okay. Yeah. Let me go back to the page and see. I don't know where I saved it.
Have you, Chris? So Chris, what I want you to do is copy this data set. Oh, hold on, this data set is not the one we're using. It is 2.5, right? Go up, let me see. No, not this one. Yeah, this one.
This? Okay.
So copy this. Okay, stop. I want you to learn how to copy, because if the data was 1 million rows, are you going to scroll through and highlight all of them down the way it was?
I know, Doc.
So what will you have done? Do that here and let me see.
Control Shift
No,
down arrow or end key.
No. Click anywhere inside and do Control A.
Okay. Yeah, that's also an option. Yeah. Okay.
Okay, copy it. Control C to copy, take it back to the R Studio. And you don't paste, before we work on it, leave a space and hash, and then type simple example in capital letters. All right, so in the next command, type require benchmarking. When you start typing, it will come. Benchmarking. Again, when you start typing, it will come.
All the same word.
No. Require bracket benchmarking. When you selected the require, a bracket must come. Did you select it? Okay, I'm sure you've not installed the benchmarking, so this is the first time. So we are going to install it on the bottom far right. Look for install. Look for packages. Under that, look for install. Install. It's on the left, top left.
Install. Okay.
Type benchmark.
Benchmarking.
And install. All right, done. Now run the require benchmarking. This is what we're going to use to do analysis. And then under that, type FAM1. FAM1 equal to read.delim into bracket, it will pop. It's a dot. Then double apostrophe. Inside the double apostrophe, clipboard, small letters. Run it and show it. Showing it means that you highlight FAM1. Just highlight that alone and then you show. No. What did you do? You copy it. Do Control Z.
Control Z.
And run. No, run.
Okay, I should run it now. Control Enter.
So you can see that the data set is showing down there, which means that your data has been beautifully loaded. Okay, that's the first thing. Of course, you can look at the head and tail of this data, but because it's already short, we don't need to bother ourselves. You can do cross tabulation. You can do contingency tables of this data. In real life, this is a whole thesis data set, dissertation data set. You can do a whole lot of things, descriptive statistics, graphical analytics. You can do that. You can do correlation matrix with p-values. You can do a lot of hypothesis testing across groups, across years, across. You can do test of returns to scale. You can do normality tests. Yes, so many things you can do before coming to the estimation of the efficiency. All of this will go into your analysis. If it is a thesis, it's going to go into that analysis chapter, which is like chapter 4 or 5, depending on what thesis you're writing. If it is a paper, it's going to be in your analysis chapter. Okay, so now this means that the data has been loaded. We're going to do something small because we are going to draw this data set. So go to the next code and you're going to type FAM, F-A-M, without a 1. And then you equal to FAM 1.
Equal to FAM 1.
FAM 1. Then bring a square bracket, not curly bracket, square bracket, not curly bracket, square bracket, and bring a comma and do -1. Okay. Write a little instruction to tell you what this is doing. Okay. This converts column 1 DMU name. This converts column 1 DMU name into row names. Into row names. Okay. So what we are doing is that, you see why they've written DMU1, DMU2. You are going to just convert them, change them. Sorry, where you see 1, 2, 3 on the far left of the table at the console down there. You see that there's 1, 2, 3, 4. That portion, we want to replace that with the names of the DMU. So that the names of the DMU are not 1, 2, 3, 4, 5, but rather DMU 1, DMU 2, DMU 3. Do you understand?
Yes.
Okay, so we go to the next command, and then you type row names into bracket farm. Into bracket farm. And then do equal to farm 1 square bracket, comma, 1. And that's it. So what is going to happen is that we are going to use the row names for, you type row names. You didn't close the first bracket, the farm. When you wrote the farm, you're supposed to do, the farm should be closed. FAM should be closed. Close the bracket after FAM.
Okay. I should open another one. Let me see.
No, you're closing it rather, you're not opening. Before the equal to, close it. Before the equal to, close it with a bracket. Before the equal to.
Okay.
Yes.
And then
that's it. That's all.
I should remove the last one.
Yeah, but because I didn't mention a bracket that you should do. Now, I didn't say you should run it too. I don't know why you're running it.
All right.
Because you've not run the first one. So why are you running this one? If you want to run this, you have to run the 15. You've not run the 15, but you are running the 16. But 16 depends on the 15.
Okay.
So run the 15. Command 15.
Can I run it together?
Are you? Yes, you can. But I want you to understand what is happening here, because that's why I explained you. Because if you just run codes without understanding codes, you will later not be able to teach anybody. Why do you still have the bracket there? I told you to remove that last bracket on the right.
Sorry.
All right. So what this one, now this last one, what it does is that it labels the new data frame as farm. Just for your instruction, you can write that. This code labels the new data frame as farm. You see, that's why when we loaded the data, we didn't call it farm or family. We were just using it, but we just called it farm 1 because we're going to change that farm 1 to farm. All right, go to the next command. So now just highlight farm alone. Just highlight farm alone. And you see that it's different from the farm 1. Highlight and show. Highlight and run. What do you see is the difference here? Compared it with farm. You can run farm again to see so that you don't have to drag.
2, 1, 2. Okay. The row names have been changed to the DMUs.
That is exactly what we want to do. Because if you don't do that, when you are drawing, it will not use the names of the DMU. It will just call it 1, 2, 3, 4. I wanted to call it DMU1, DMU2, DMU3, DMU4. Okay. Now we are ready to do some few things. Let's create the input matrices and the output matrices, the constraints. Okay. So the next thing is to create an X. So do small x equals to cbind into bracket farm $x1. You see the x's have come. Okay. Farm $x1, comma farm $x2. So what we are doing here is that we are combining the headings, the x1 and the x2, as inputs. So we are calling it all x. So if the inputs are 13, you will do all of them and create a matrix for them, call it in X. Okay. So the data frame that you have, which is farm, we are peeling out the X1 and X2 together. Run this and show it. Run this and show the X. And you will see how the X looks like. Show it, show it. When I say show it, you don't need to type it. Otherwise, you're going to always be typing. You just highlight it and show. So it has peeled off just the input together. And we can do the same thing with the output. So do the same thing with the output. Just do the same. Y equals to
Y equal C bind. Dollar Y1.
No, it didn't have Y1. Stop. I thought you were going to be able to recognize. So when the set came, you should have known that there was no Y1. There was only Y.
Oh, only Y, yeah.
You're going to recognize. That's why I kept quiet. So it's only Y. We don't have anything else. Remember, the outputs were normalized. Run that and show. And you see that they are 1-1 because that's what we said we're going to do that. So note that what you just did is combining the input matrix or creating input matrix as well as creating the output matrix. Okay. Now we don't need the prices of the input. The W's are the prices of the input. We don't need that. We are not doing cost efficiency, so we'll leave that for now. So we go to the next command, and what we are now going to do is we are going to draw. Okay. But before we draw, we want a very good labeling. A very good labeling. So let's create X1. So type X1 equal to farm square bracket, comma, and then you do C. Okay, we are concatenating again into bracket double apostrophe X1. Good. You do the same thing for X2. You can copy the whole thing, paste it down, and edit it for X2. Because we are going to plot the isoquant. Remember, all along, the graph we were using was something like the isoquant, the convex isoquant. So that's what we're going to do. Okay, so what is this? We are renaming the X1 as input X1. That's all we are doing for purposes of drawing. I normally like you to write a couple of instructions so that when you are always, so this renames X2 or X1 as X1, X2 as X2. So it renames X2 as input as X2. All right. So we've been able to create this. The next thing to do is to create the next thing to do is to create a plot. So type plot. We're going to just create a scatter plot of the data set. So plot into bracket X1, comma, X2, comma. We can give it even a title. Okay, so after the title, after the X2, do COL for a color. Equal to. No. Do equal to. And then bring a double apostrophe. This is good because whatever color you take, it will use that color. Okay, you chose red, it has a red the color. So that's fine. Step out of the double apostrophe, stay in the bracket, and do a comma. Type line width, LWD. LWD equal to 2. You can change the line width anytime you want. Then do a comma. Type PCH. That will also give you the kind of symbol that you are trying to use. Let's say it is equal to, so you see the PCH, it was telling you what it was. Did you see that?
Chi-square.
It says that the density distribution function, quantile function. Oh, no, not this one. No, not the pi square. Okay, this one just tells you the sort of the position of some of the things that you need. Anyway, the PCH is like the symbol type. You know, whether you are going to do a scatter plot, whether you want the scatter plot to be box or to be a triangle. Okay, so we got to choose a number, and that number will help us to know what symbol we want. So if you choose 0, it's going to be boxes. We don't want that. If you choose 2, it's going to be like triangle. We don't want that. If you choose 3, you're going to have plus, 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 plus for each scatter plot. And if you do 4, you're going to have times. If you choose 8, you're going to have star. So let's choose 8. You can always change it. And do a comma. Then you have the next one, which is CEX, CEX, equal to, let's choose 1. That is the size of the symbol. The size of the symbol or the size of the text. So we chose 1 for the text. Still stay in the bracket and do comma and type TXT, text, TXT equal to capital true. So in this case, what you're telling it to do is that the names that we use, that's the name that we want to use also. You can give it a title, but here I don't want us to give it a title. So that's it. So on the bottom right, you got to make it a bit bigger because it's going to show bottom right box. But not too big like that. All right, so run this command and then the picture will show for the scatter plot. Okay. It says that X1 not found. So maybe you've not run 19 and 20. Run 19 and 20. Okay. So now you can see that it has labeled the X1 and the X2 the same way we did it in Excel, isn't it?
Yes.
You can see that I told you about the PCH that we wanted a star. That was number 8. If you go and change the PCH to 3, change it to 4. It will convert and run it. It will convert everything to times instead of stars. Run it and see. And again, if you change it to 15, it will give you a box, but it will fill the box. It's just for you to know how to play with some of these things. Okay, so now that you know, at least you can go back to the 8 and keep it a star. Okay, so now you've been able to scatter plot the thing. That is how the thing is, that you have the X1 and the X2 also labeled because we instructed it that it should label it. Now we are ready to plot the orientation itself. Okay, so type plot. We are going to plot the isoquant. We're going to create an isoquant. So you type plot equal to, plot bracket X1, X2, Then orientation in capital letters, comma, orientation. As you type orientation in capital letters,
All in caps.
yes, all in caps. Then you do equal to double apostrophe IN. IN stands for, have we run the require benchmarking? Have you run it?
Yes.
All right. Step out of there, still stay in the bracket and do comma, capital RTS. That's the return certificate equal to double apostrophe CRS. Comma, line width, that is LWD, equal to 5, comma, PCH again, equal to 4, comma, CEX again, equal to, let's say 1.25. I'm just showing you a different way of how this thing interestingly works. Now, comma, COL, you're going to change the colors. And then after COL, I'll bring equal to C, bracket, double apostrophe, blue, step out of the double apostrophe, small letters, and do a comma. Do the same thing for red with a double apostrophe with a red inside, purple, and then do green. Just do different ones. You're going to see something interesting. No, you don't need to write the C again. They are all following the blue, the red,
Okay.
All of them. But you just copy the blue and paste.
Okay. So red or green.
Always use small letters.
Okay. That's it.
Do another one. Do a comma and do another one. Red. Why is a bracket 3? It's supposed to be 2. I don't know what you're doing then.
From here we have 1, 2. Okay, maybe I typed.
All right, so run that. It will give you another different flavor. So what you can see here is that it has given a different color to each observation. Now, this is true when you have groups. So you have your observations, but the observations are in groups. So let's say that you have foreign banks, you have domestic banks, and then you have that, and you want to differentiate them by colors. Do you understand?
Yes.
So you still do the plot, but you differentiate them by colors within, so that you know that the red are the state banks, the blue are the foreign banks, and then the green are the private domestic. All right, so that's a different flavor of the plot. Now let's go to the final estimation, the actual. So we are going to run the D. So type DEA.plot. No, keep going. Still follow that. We're going to draw the DEA frontier. So type DEA.plot. Then bracket X1 and X2. X1, comma X2. Remember, these are all small letters, even including the DEA. And because you made the DEA capital, that's why it didn't get an option. Stay in that bracket. You're going to stay there for long. So you see the same thing you had up there. In fact, I would say that just copy 22 and paste it for the 23. And instead of the plot, make it DEA dot plot. Okay, now this is a frontier we are going to create. So obviously it's going to take just the first color, even though you have other colors, it will not take the others. It will just take the first one. Okay, run that. Okay, so you have a couple of errors.
Oh.
Okay.
CRS.
So I asked the question of whether you have
run the benchmark.
Yeah, you said yes. So go and run it and let's be sure that's run.
It's still loading.
Says there's no package. So the benchmark you have there is capital. So the B is supposed to be capital.
Okay.
Key typos are punishing you. All right, now go and run the 23. Now, if you didn't know that it's because it's capital, that is not capital. That's why it's not working. You will be stuck there. Okay, so you can see that now you've been able to create the frontier. Now, we can choose not to deal with this one where we did different grouping colors. You can go and run 22, run 21, so that we use where all the observations were red. Okay, and then come back and run the 23, so that we just focus on this one. The other one, we're just showing the grouping. Did you run 23 or you run 22?
I ran 23.
You did? Oh, okay.
Or should I remove the 22?
Remove the two colors, the green and red. Okay. I think I know what's happening. It's picking them. It uses.
It's using only the blue.
Yeah, it's using the one color. Okay, no problem. But at least the key point is the ability to draw. You can later change using the previous coloring or audit the coloring or use the classifications to be able to change the colors. But the key point is that you've been able to draw the thing, but we haven't labeled them, isn't it?
Yes.
We have not labeled them. So let's label them. So type for FOR, the next command, type FOR, bring a space, select and bring a space, and then do brackets, small I, space, IN, space, 1, colon, length,
Semicolon.
colon.
Colon.
Okay. You type length and into brackets should be wide. Okay, step out of the two brackets, bring a curly bracket. And inside this curly bracket, there are some strange things you're going to write. So first type lines, all small letters. When it comes, select it. And inside this bracket, type C, then bring a bracket again. After C, bring a bracket again. Inside the bracket, type 0, X1.
Alphabet 0 or number 0?
Number 0, the actual number 0. X1. And then after the X1, bring a square bracket, and inside the square bracket, I. Step out of the square bracket and the brackets and bring a comma. Okay. So we're going to do the same thing. What we've done it for X1. If you check it carefully, you can copy that same thing on the left of where the cursor is. Up to, hey, wait, you're copying too much. Up to C, and then you come and paste it. Remember, you should not copy anything else up after the comma. So it is C going to the right up to the comma, up to the last comma on the right. So from C going to the right up to the last comma. Copy and paste it after the comma.
Okay. Does that work?
Have you done the right thing? Do you think you've done the right thing?
C to S2. Because this is one block. The bracket is indicating that it is one block.
Let's move on. So bring after the comma, bring LTY. That is a line type. LTY. That is a line type equal to double apostrophe. And we're going to choose a couple of lines. Let's use dotted. So type dotted, double T. Step out of the double apostrophe. Comma. Line width, LWD, equal to 2. Comma. Color. Let's call the color black. COL equal to double apostrophe. Inside that is black. Okay. So that is going to put the names of the DMUs on top. Run that, and hopefully you should get to the names of the DMU associated. Okay. So obviously, I expected that you were copying, there will be some errors.
Yeah.
You did not say yeah.
C0X1I. So must be here.
Have you seen where the error is?
Line C, yeah, the error 0x1. Yeah, okay.
Run it and see.
What I've highlighted.
No. Run the. You said you corrected the errors, right?
No, it's indicated here, but I don't know exactly where. You can see the output. It's telling me.
You knew the error you are going to correct.
So I'm following I think here I'll have to. Zero X1, 0x2. Close.
Okay, let me see.
This is in X1, comma. The cube. 1.
So you have a curly bracket, and then the curly bracket ends at the far right, right?
Yes.
Begins before the lines, and then after the lines, you should have bracket C bracket 0, comma X1 square bracket. Inside the square bracket is I. Do you have that?
Yes, but after the S1, we have comma.
No, there's no comma.
Okay.
That's what the issue is. And you should do the same thing with the X2. Yeah, now
Okay.
run. Okay. So this gives you the radial lines for each one of them. You get a radial lines. Oh, I didn't bring the text. The text should come before even the radial lines. So go to command 24 and type in front of the FOR, create a space, and then write text, T-E-X-T, then bracket X1, X2. And then comma, row dot names. Because that's the names of the row dot names. And then you write FAM. Because you have already told it to. Step out of the bracket, bring a comma, sex, CEX equal to 1, comma, POS for the position equals to 3. And then comma, color to be blue. Now you know how to write color. All right, so run that. So you see that each DMU is giving their actual names, and then their radial lines have also been drawn towards the origin.
Okay. Yes.
So all that we had, we have been able to bring it here. So when you're writing your thesis, normally it's nice to demonstrate how this works and then take this picture into your thesis. Of course, every model, you can draw something related to this. There are, of course, different drawings. So this is it. This is how you estimate this. Now we are done. We can now go ahead and run the efficiency scores under CRS and VRS. Go to command number 26. So 26, type TECRS. That is technical efficiency CRS. Equal to DEA bracket XY. Not square bracket, I say bracket. You're going to write square bracket.
Okay.
X, comma, Y, comma, RTS. Capital. RTS is capital. That's a returns to scale.
Scale.
Equals to double apostrophe CRS. Step out of it, comma, orientation, capital. Orientation. Equal to double apostrophe input for IN. Comma. No, don't write input, IN.
IN. Okay.
Step out, comma, slack, capital, slack. Select equal to T, capital T, for true. So what you're telling is I want you to estimate the technical efficiency scores, and also if there are slacks, bring the slacks and let's see. Copy the same thing, paste it down for the VRS, and change the CRS to VRS.
CRS. Okay.
So run and show. It will give you the efficiency score for each DME. And if you remember what we did practically, go and highlight the constant returns and then the variable returns to show the results. In this case, you will get the same results because they are all within the same corner.
Okay.
You remember that DMU A was inefficient with a 50%. That was the one with the slacks. And you remember that DMU 2 and 5 were efficient. Do you remember?
Yes.
But looking on the graph, you can
From
see.
the graph, yeah.
But one thing you should notice that in real life, you can't draw a graph because the inputs are more than X1 and X2. And the outputs are also not normalized. So it is the results you use to judge, not a graph. You can also find a summary of the scores. So you just type summary. The next command, type summary into brackets TECRS. So it will give you a summary of the efficiency scores when you run it. So you see, it has given you so many things there. When you scroll up, you see that it's saying some things. What did it say?
Summary of efficiencies. CRS technology, input orientation efficiency. Number of firms with efficiency straightly equal to 1 are 2 out of 5.
And I'm sure you remember those two. Again, on the graph, you see that they are 2 and 5.
Yes.
And then it also gives you the mean efficiency for this industry. Those that are below 20%, those that are between 80 and 90% go down. And those that have a score of 1. E equals to 1. There are only 2 of them, and they make up 40% of the data. So it gives you a bit of quick summary of the results. As far as interpretations are concerned, you know how to get it. But normally, we don't want the results like this. We want the results in a proper shape, printed out. So there are some few things you're going to do. Number one, you're going to print out the results properly. So type print into brackets, cbind, and you're going to do, what is that? I'm not going to use X1. You have double apostrophe inside that have TECRS close double apostrophe. Step out equal to, write it TECRS $EFF. Okay. Bring a comma. So what it's going to do is that it's going to find the technical efficiency scores under CRS, and it is going to call it TECRS. So that TECRS is the way we want it to show in the table. Copy that same thing and paste it on the right and change CRS to VRS.
Please, after the comma, we don't write anything.
No, copy just what is in the bracket from TECRS together with the double apostrophe, just that one, and then paste it after the comma, right after the comma, so that we can edit it for VRS. And remember, it doesn't include comma. Okay, so change the CRS. No, you should bring the comma, but you still have CRS there.
CRS.
The second one should be VRS.
Yes, so it's VRS.
It's not.
Okay, yeah. V.
After that, bring a comma and write digits so that we'll restrict the digits. It's a bring a comma. I didn't say full stop. Equal to 3 digits.
It's comma equal to 3.
Yeah. All right. So print the results and see. You get a results in 3 digits and a beautiful table. I don't know why this one.
When you say 3 digits, what does it mean?
It's supposed to be in decimal places.
Places.
But I think that doesn't show. So let's do round. You know something? Bring round before the printout. Bring round. And then bring a bracket after the round. Good. And then go to the digits, remove the digits and the 3. And then remove that comma there. And then step out of the first bracket and bring a comma. I don't know whether it's the first bracket or second. Write 3. I've forgotten which one you have there. Run this. It's going to be wrong, though.
It's 1.
It's not 1. Go up. Go up.
Okay.
Yeah. But maybe close that 3. Delete the 3 and the comma and bring the comma after the last but 1 bracket. Here, there, let's see. Yeah, this is much better. Still. One of them.
This is 3 decimal places, right?
Yeah.
And that's what we wanted. Oh.
Yes, but then why is the other one shown?
I
wasn't expecting the other one to show. But I wasn't expecting the other one to show. Anyway, but that's it. That's it. This is just looking for, you can always learn how to write which decimal way you want to write. But that's the main thing here. The next thing is to draw the kernel density plot for the efficiency score. So type EFF.DENS. EFF.
I'm coming on. Kernel.
So that's like a smooth distribution of the data set, of the scores in this case.
Okay.
Obed, have you given
EFF?
EFF.DENS. DENS is for density. It will come, dot plot, it's down there. EFF.dens.plot. Good. And then into brackets, TECRS, technical efficiency for CRS. So just type TECRS, comma, line width, LWD equal to 4, comma, COL is red, color is red. Okay. It will draw the kernel density plot for this score.
I can run it.
Have you run? Yeah. So this is a kernel density plot. Now, 2 of the firms had efficiency score of 1. Do you remember?
Yes.
So that means that there's a lot of concentration of the scores at 1. Do you agree with that? You get that?
A lot of concentration because 40% of it was
scores, which number is appearing many times?
1 by the plot.
So that means that the mode is 1.
Yes.
And in a normal distribution curve, you will notice that the number that has the mode, that number will have the greatest peak.
Yes.
The peak of the graph, the histogram or the kernel density, it will be higher at that number. That is why you can see that 1 is having the highest point of the. But even though 1 has the highest point, the curve is not normally distributed. Do you realize that?
Yes.
Which leads us to one major conclusion, that efficiency scores are not normally distributed. they are skewed, in this case, to the left. They are skewed. They are left skewed here. In other words, the left portion is smaller. So that is why we normally call it non-parametric.
Okay.
If majority of the numbers were 0.6, you see that the peak will be at 0.6. In other words, the peak of this curve will be at 0.6, which makes it a bit more normally distributed, isn't it?
Yeah, and then this will come down.
Yes, it will come down. So for your information, efficiency scores are always peaked at 1. There's a high probability mass, we call it, at 1. So that is how, you see, this is just 5 observations, but if you have 1,000 observations, which is what happens in real life, you will see that the graph will showcase a lot of interesting points. Now, if it is output orientation, remember that the output orientation, the scores are 1 and above. So if it is output orientation, then you would expect the scores to be 1 and above. So again, the peak will be at 1, but then it will not be below 1 as you see the other numbers. There are different ways of drawing the density. Okay, not just, there's another way of drawing the density, which sometimes can look even beautiful. Now let's do that one. Set type library into bracket plot2. It's a package we have to install first. Okay, before that, just before that, so I think you should go up and create a space. Type install.packages into brackets $plot2. I think
I've already, hopefully I've already installed it.
But if you have, then it will do it quickly. So run that. No, you haven't.
No, I haven't. All right.
Okay, now library it is loaded, so library it. Run the library. Okay, so it's loaded. Let's write a certain command that will show it. So type plot into bracket density. Plot into bracket density. Then left bracket again. And then write TE VRS. This time I want to use VRS. TE VRS $EFF. Step out of the first bracket, bring a comma, then the color should be blue. Step out of the, still in the bracket, comma, the line width should be 6. Step out of the bracket this time, bring a semicolon. Then type RUG for RAG, RUG. And then bring a bracket. Inside the bracket, have jitter, JITTER, jitter. Then bring a bracket and then choose TE VRS $EFF, the same thing as you had after the density. Okay, run this. You see that it's a slightly different density plot from the previous one. Okay. You see, it sort of normalizes the density plot. It gives you a couple of bandwidths during the normalization process. Now, it doesn't actually, it's not actually showing the, how do you put it?
The efficiency scores.
Yes, but it's showing, even though it's not actually showing, it's normalizing the efficiency score. And at the bottom, you can see that we brought a rag, a jitter. Now, what the jitter is doing is that it just shows a possibility of where there is a concentration. So if there's a lot of concentration, you will see that the jitter will be highly concentrated there. And you can see that at 1, there appears to be a sort of a double concentration there. Do you see that? Of the jitter. The jitter is that small vertical lines at the bottom.
Okay. Yeah, I can see two of them at 1.
2 of them are concentrated around the 1.
Yeah.
And then there is appear to be 1 jitter between 0.4 and 0.6.
Yes, and 1 between 6 and 8.
The efficiency score we had, we had efficiency score of 0.5.
Yes.
If you check your efficiency scores, you see all that on top. In fact, you can run just the efficiency score. Just run T, highlight T, E, VRS, and then run that alone. And then you can see the efficiency scores below. So you can see that efficiency score for DME2 was 1. Now for DME3, it was 0.83. So when you go to 0.8 here, do you see that 0.83 seems to have something, a jitter there?
Yeah, yes.
Okay. Then
7.
we have 0.7. 0.72 has a jitter below 0.8. If you look at the graph, below 0.8, yes, there's a jitter, a vertical jitter there.
Yes, for the 7.1.
0.8, there's also a vertical jitter there. So the jitter is telling you the positions of the numbers. But if these firms are 1,000, then the jitter, you will not see it like the way we are seeing it. So where the jitter is concentrated, that is where the peaks, some of the peaks are. Remember, the peak we are having here is 1 peak, 1 major peak. But in real life, there could be multiple peaks, but there will surely be a lot of peaks at number 1. Okay, so number 1 will have a lot of jitters right there. So in real life, even though you will not see the numbers, it will tell you. You see, it's good to talk in probability terms. It's good to talk about distribution than central tendencies. Central tendencies is just the mean, the median, measuring the center. But then the distribution will tell you the concentration. So here you can see that there's a lot of concentration of the numbers at around 1. Around 1. That's where much of the jitter is showing itself. Anyway, this is a beautiful way of showing the distribution. See, unlike the previous one, this one actually puts the density in a proper shape. In other words, it gives you a kind of a smooth density graph that expresses the distribution and even the potential distribution of the data. So you can see that we don't have efficiency scores at 1, but there's still supposed to be some sort of, the graph covering 1, but it's not really necessarily covering 1. It is distributing the whole efficiency scores as though if somewhere there, this is how it should be normalized. Yeah. There is another one, okay, that you can check later. That's all in the graph, in the slides that you should check. Now, let's go to PS. You remember when we did this thing, we looked at PS.
Yes.
Okay, so type PS into brackets TECRS. No, this is a commando. Okay. It'll pop.
Is it TP or TEVRS?
Technical efficiencies. Either of them is fine because they are the same in this context. So when you run it, the first column is going to be the DMU names. Run it and see. So you see, the first column will be the name of the DMU. So DMU1 has got how many PS? 2. Well, no. When you look at it, all of them have got 2 PS.
Yeah.
Isn't it? The PS are Peer 1 and Peer 2. But DMU1, it has used which DMU as its peer? DMU2. So DMU1 has used DMU2 as its peer. Now for peer number 2, it doesn't have any. So what it means is that it is copying solely from who?
Itself.
Cannot be itself. DMU1 is copying solely from who?
2.
And DMU2 is copying solely from who?
Itself.
DMU3 is copying solely from who?
It's copying from 2 and 5.
And DMU4 is copying solely from who?
It's copying from 2 pairs, DMU2 and 5.
And DMU5 is copying from who?
Itself.
I'll give you some of these things in an exam, actually. And then I ask you questions based on this data set. Okay. So based on the data set, you should be able to know how many pairs are this, how many pairs are not this, and all of that. Okay. Now, so by looking at just the pairs, you'll be able to know which firm is the efficient firm. So based on this, which firms are the fully efficient firms?
From 2 and 5, and DMU 2 and 5.
That's it. And because and when I ask you what is your reason, you should be able to tell me the reason, because they are the ones which have been used as peers. If you are not a peer, you will never be used. If you are not efficient,
you will not be peer.
Yeah. And I mean not just efficient, but fully efficient. Fully efficient, Pareto Koopman's efficient. You will never be used as a peer. Now, but let's assume that we rather want all the total number of efficient peers. So type this and let's see. Get.number.peers. Get.number.peers. It will start popping. And then you type the efficiency score, you add up the TVRS.
TVR, okay. I should run it.
Yeah.
Okay.
So what does that tell you? It tells you that for DMU2, the number of times it was used as a peer. So this one is just peer analysis. Okay. In this firm industry, only 2 firms were used as peers, DMU2 and 5. Okay. Now, the number of times DMU2 was used as peer was 4.
Yeah.
And the number of times DMU5 was used as peer was 3. And again, when you go to the app 1, you can count it. So if you check 2, how many times did 2 appear?
It appeared 4 times.
And how many times did this 5 appear?
3.
Now, of course, you can count it here. But in real life, do you think that you can count it? So normally, by looking at this other part of the data, you should be able to make sense. So these are practical things that management love to hear things from. Okay, now we are left with the very last one for today, and that is slacks. I think if there's time, we'll do not just slacks. Slacks. So type SL equal to slack. It will pop. Then you bring a bracket X, Y, TEVRS. So this will calculate the slacks. We call it the maximum number of slacks. So run that and show the results. Just show the results, SL. So this will tell you which DMU is having a slack. And if you can remember the graph, even if there's no graph, Which DMU is having a slack? I mean, looking at the results, you don't need to go back. Oh.
The result is the first one.
Yeah, it's the first
DMU one.
Remember, in real life, you'll never need results. So it helps you to know those that are slack. But the question is that which slack, okay, which particular input, which particular output. So this one doesn't tell us which input or which output. So we need to find the exact one. And this time, I want us to even put it in a data frame and add all the rest to it. So type data.frame. And you're going to add everything, including the data set. So type data.frame in bracket FAM, comma, TECRS $EFF, TECRS VRS $EFF. Then we're going to calculate something interesting. We'll come back to this. Go on top of this. Go on top of this. And then do an instruction called scale efficiency. Let's quickly put the scale efficiency there. It's an instruction. You have to bring a hash symbol in front.
All in one. Oh, okay. As a comment.
Yeah. And then under that, type SE, small letters, equal to. And then you can do the TECRS $EFF divided by TEVRS $EFF.
I will read this as division.
Yes, leave it. That's why I scaled it.
All right.
Run it. And then go to what you were typing before. After the comma, add SE for the scale efficiency. You would have calculated it. Then do a comma and add SL $ slack. SL $. By the way, I said SE. I didn't say CL. Sorry, SL, okay. Not CL. And then the other one is SE, not C. I don't know. You hear S or C. Comma. And then you do the same thing. SL $SX. Silicon xylophone. Is there. You can pick it. SX. Those are the things you get from the scores. Comma. SL $SY. So I just wanted to know that the SL $ slack, it actually deals with the number of slacks, then the input slack and the output slacks. So you give both of them. So this is going to put everything into a data frame nicely. Run this.
Okay.
So in a data frame, you can see that it has your DME name, the inputs and the output, the data set itself, the efficiency scores follow, that's the CRS, the VRS follow. The scale efficiency is 11111 because I told you that the CRS is the same as the VRS. Then the slack, it tells you whether a particular DMU has or does not have a slack. It's like a Boolean.
Yeah.
So you can see that the first one, it tells you that it has a slack. Okay, then it has to give you the actual value of the slack. And you can see that it was 0.5, but now it was not 0.5 under the X1. It was 0.5 under the X2. So as far as this DMU1 is concerned, it's fine when it comes to input X1. There's no slack there. There's no inefficiencies there. There's no leftover resources there. But then when it comes to the X2, it has a huge 50%, cut. 50% rise in the X2, which it shouldn't have. So that is where the slack is. So you're able to get a lot of information with this. Next time, we'll continue with the lambda. The lambda is another means by which you can determine the other things in there. But we'll use that lambda to find the targets. Don't forget, we'll identify the targets, and we'll first identify the lambdas, and then we'll use the lambdas to find the target. You remember that I told you that management are interested not in just the score, but they're also interested in what they can do to reach the better point.
Yes.
That's it. Any question?
No, the only question is, these codes, are we supposed to keep it in mind, or we should just know what they are doing and then we reference it when we are doing the coding?
You know what they are doing. You will never have to memorize these codes. In real life, whilst you are doing it, there are so many information online. In fact, that will tell you, if you tell you, I want a code to calculate the slack, you get a code. But you have to learn, like you've just gone through. You have to know what each code is for. For example, this one is for input. You're not going to use it for output.
Yeah.
But apart from that, you don't need to memorize it. Even the RSL has got its own help that will give you these codes. But you have to edit it to suit your own. See, I called my data set FAM. You can call your data set Chris or C. You should just know that this is a data set. Obed. Wadao.
Doc. So
what did you learn?
I learned with the output, there are so many ways you can use it to determine the efficiency, the DMUs, and so many things. I'm going to follow and then do the practical example when you upload the recordings on the internet. Then I have to follow and also see if I can practically use it.
Yeah. So, Chris, is there something you learned through all of this exercise?
Yes, it's how to implement what we learned over the past week or 2 weeks in R, essentially.
Okay. So the thing is that by typing these things yourself, which is what I wanted Obed to do, by typing these things yourself, you are able to feel the rhythm of what is happening. You get a point. You're able to now know what is happening. At the end of the day, you can take this data set into Excel, talk about it, create multiple graphs. We've not even come to the graph. They're beautiful visualizations that you can use to make these points stand. Okay, there's no question. That brings us to the end of the entire